All right, so I'm going to get going with the reverse path presentation. This is 10, wow, webinar number 10 this year for our Webinar Wednesday series that we've been doing the last Wednesday of every month. Uh, last Wednesday, or yeah, last month, we dove into video on demand a little bit, and we talked about OTT and streaming and kind of traditional services like patient engagement services that are using RF communications on the return path or on the push side of things. And we're going to kind of take that same concept and use it as a leader into, well, how does Z-band deal with those systems? How can I pass Netflix through my ZHC platform? Or how can I do patient engagement in a healthcare setting and only use one data cable using the Z-band platform? And that's really kind of what we're going to dive into today. And what's worth noting about that as we're talking about this from a Z-band standpoint is there's really two different ways to communicate back to our system and two different methodologies for making sure that you're getting information back to the head end. And we see both of these in the market right now with different vendors. So you can do your reverse path communications as RF. And we're all familiar with this concept from our cable set-top boxes. Maybe not so much the ones that we're doing today, but previous cable set-top boxes in the 2000s and the 2010s, really up until the last 5 years or so. If you were doing video on demand, if you're doing pay-per-view, you were doing meal ordering, yeah. If you were doing upgrading your channel plan, any of that kind of stuff while you were working on the set-top box, um, you were sending a reverse path RF communication all the way back to your service provider CMTS for them to be able to capture that information and say, okay, we're going to release this VOD programming or we're going to update this pay-per-view content and allow the client to be able to see it. For those of you who traveled in the 90s, 2000s, early 2010s, you had your LodgeNet system in the hotel. That's exactly what that LodgeNet system was doing. When you were ordering whatever content you were ordering off of the TV screen, that was a reverse path RF communication back to say, hey, this is what I'm looking for. Can you please send me this content? And there are still technologies in the industry that are using that today. And more importantly than that, there are a lot of our legacy clients that have systems who are designed around continuing to use that RF reverse path. So it's not necessarily the buzzword. It's not necessarily the sexiest thing in the world in terms of talking about top line technologies and the leading edge, but it is also something that's widely deployed. It's something that had been widely implemented and is still something that we need to support as Z-band today as we're moving forward. So we'll spend some time on that and how we're doing that in the new iteration of the system. If you're not using RF, the obvious easy way to do it is reverse path communications as data. And we have two different options for doing that. We'll walk through those and the positives and negatives of doing things either through the top row, bottom row system or through the internal switch. And really, it's going to be a customer preference thing. It's also going to be a question of what else you may be supporting within that infrastructure. And we'll talk through those things as we get through the webinar. I think the thing that I want to stress up front here is the reason for this webinar is because when we launched the ZHC, this option, make my laser pointer out, for reverse path communications as RF didn't exist. We took it away. It wasn't something that we were seeing a ton of in the field in terms of a new leading edge technology. And then we were wrong and had to go back and build a device or a system that would support that because of how many of our clients in the field have that reverse path RF communications. We also took away this top row, bottom row configuration to pass data. It had been there in our third generation, our HD 860s. It's there in our fourth generation in the HD 1000s. And then we took it away for the ZHCs because, again, we believed we could just push that through a layer 2 switch for data communications. And we've had a lot of clients who have had objections to that for very reasonable objections. That's kind of forced us to go back and reconfigure this top row, bottom row, and make it available again in order to support our client base. So some of the catalysts for this webinar and some of the reasons that we're doing this particular webinar is because that we've messed up in the past and would like to be able to fix those problems for our clients and get out a product that works and supports all generations of Z-band systems that are in the field and all generations of technologies that are out there and not just hours. Uh, so RF reverse path. The RF reverse path is different than what you've seen if you have a Gen 3 or a Gen 4 system. If you have a Gen 3 or a Gen 4 system, you have these 8 outbound cascade ports, but then adjacent to those, you also have 8 inbound cascade ports. And that's how we did RF reverse path in healthcare or in hospitality. If you had like a Sonify system or a LodgeNet system, that was how that was done. The new generation actually embeds an internal fiber transmitter into the rear panel of the ZHC and sends through a single strand of single mode fiber that sub-channel communications frequency back all the way to the head end. So this moves us, number one, from pulling additional coax to now being in the world of fiber. It embeds the fiber transmitter in the ZHC, so it takes away external devices that we need to worry about in the rack, and it moves us to single mode fiber from a communication standpoint, which is great because that's the direction, or fiber is the direction that a lot of our clients are going anyway. You do see it in this bullet up here. This is still a home run. So this single mode fiber is going to come out. It's going to the fiber tray, and then we're going to drop that all the way down to the head end where it's going to get recombined and go to the server or management platform of whatever system that we're sending reverse channel communications back for. Now, full transparency on this one, most of the time, this application right now is for Sonify in healthcare. Their patient engagement system, engagement platform is offered both as RF and as IP. But if you want your video and television content delivered as RF, then they prefer to keep their reverse path communications and all of their backwards communications as RF as well. So you end up with a system that has got this full reverse path RF design. There's the downstream path for the television channels themselves, and then the reverse path for any of the content ordering and content interaction. The other thing that they have, and we'll cover it when we get into the next slide, is because they're using RF for reverse path communications, this is not the standard Z-band Balun, which is our standard Balun UNV, because the standard UNV Balun doesn't have a diplexer in it. And the reason that a diplexer is important is it is what opens and closes the reverse path communications channel when you're interacting with the Sonify system. Or I'm going to use cable set-top boxes as an example here, just so that I have something a little more widely deployed to speak about, versus healthcare is kind of or Sonify is kind of a healthcare specific example. So what happens with the diplexer and why there's a unique Balun required for these reverse path systems is you have all of your standard broadcast content, which is going out, and the cable TV spectrum starts at 54 megahertz and traditionally ran up to 860 megahertz in the US. It goes higher than that now with the new DOCSIS standards. But when we're talking about it, and for the purposes of this webinar, the important part is that it starts at 54 megahertz. Anything below that is known as T-channel or sub-channel communications. And that is where Sonify places their reverse path content. So you need to have a diplexer within your system that will open the appropriate frequencies when it hears that broadcast. And the reason we want to have that diplexer in there to open the reverse path only when it's necessary is we don't want to keep that reverse path channel open the entire time. It'll introduce noise into your system. If you are working with the service provider, that noise can get all the way back into like the service provider system and into their CMTS and cause all kinds of other problems. So you want to have that diplexer in there because that's going to open and close that communications channel so that it's only open when it's appropriate. And that same concept applies when we're talking about cable service provider set-top boxes. Now, the big trick with cable service provider set-top boxes is it used to be pretty standard. There was cable TV was 54 to 860 megahertz. Everything below 54 was T-channels. So any set-top box communications from your cable service provider lived underneath 54 megahertz in the frequency spectrum. Anyway, now with DOCSIS 3.1, and as we've moved forward, that reverse path communications has moved up. And now the communications path all the way back to the service provider goes as high as 225 or 250 megahertz. I think it's 225 off the top of my head. is roughly where they're at. So there's a lot more content that used to be TV channels that in the new DOCSIS standards is actually going to be designed for reverse path communications and reverse path content. And that makes designing for cable TV systems a lot more difficult because, well, the general position of Z band is that we do not support cable TV set top boxes. And the reason for that is the communications frequencies have changed so much that it's a custom diplexer or a different diplexer than we traditionally used in the previous versions of the platform. Then also the variability within that. It is not um, we have to know basically on a project by project basis or a set top box by set top box basis what reverse path frequencies it's using, what version of DOCSIS is it supporting, and without the ability to be able to answer those questions and know those things, we can't appropriately design a system. So it's been easier for us as Z-Band to take the position of 99% of our market is commercial clients in healthcare or hospitality or corporate. So we expect to see a head end and not reverse path communications from a cable set top box. From a technical standpoint, the capability is there in the devices, but for the most part, when we are talking about RF reverse path, we are talking about healthcare systems that want to use RF channels to speak back to their head end controller. I pause here because a lot of times when I'm having these conversations about system control, there's some confusion over what reverse path communication is versus just kind of general RF communication. And so, like LG has their pro-centric system, Samsung has what I think is called Link Reach or Samsung Reach's platform. Those are also TV control platforms for their commercial grade um, smart TVs or healthcare grade smart TVs. The big difference here is if you have an LG Procentric platform and it's using that RF control channel, it's actually just using an RF control channel to send content out and not necessarily, there's no reverse path, there's no validation of that communications channel. And you can go into if you have a Procentric LG TV, you can get into the engineering menu and then you can actually go through channels. I think it's 2 through 125 they make available. I don't think they go all the way up to the top of the frequency spectrum, but you can go into the LG menu and actually set the frequency of this downstream communications menu. And what they use this for is I've seen pushing channel lineups, just basically simple updates in this like pro-centric system to tell the TV to kick the TV with some communications and say, hey, we have something for you here. So I did want to just kind of touch on that because it's an ancillary technology and it's adjacent to some of the Sonify reverse path stuff that we wanted to talk about, and it is very much using RF for those downstream communications. The only thing that you need to be wary of is just making sure that you don't have channel mapped over the top of their communications channel. But is something I wanted to touch on while we were doing this webinar and talking about RF communications. As we transition out of RF communications and into IP communications, this is a picture of a device that probably most of you on the call haven't seen. Maybe none of you on the call have seen. This is a reintroduction of an older technology that has been around since at least the generation 2 of the Z-band platform. And now we're no longer using RF to communicate back and forth with the system. This is going to be IP data for any reverse path communications. And what's happened, you have a Cisco switch or a Netgear switch, whatever it would happen to be, that sits up here. I'm sure I'm irritating some switch vendor who I'm not naming. So generic switch sits up here. That's going to port is going to come out of the switch into the top row of the Z-band device. Physically, pins 1, 2, 3, and 6 are the only pins mapped from the top row to the bottom row. All of the data gets carried on pins 1, 2, 3, and 6. All of the television content gets carried on pins 7 and 8. And we have this one-to-one relationship between switch ports to television ports within the top row, bottom row ZHC. Now, some of you on the call know what this looks like in your environment with our HD 860s and our HD 1000s. This is the traditional way that Z-band always did data pass through and always put data and television on one cable. I do want to stress here that this is not the only technology that you can use that for. We've had clients who have used pins 1, 2, 3, and 6 for RS-232 or RS-485 systems. We have had clients use pins 1, 2, 3, and 6 for analog phone systems and control platforms. We had one client, I believe in Florida, who is running cameras from the patient room through the top row back out and then pulling it into some sort of recording platform, and that's how they're doing their patient monitoring. Our clients have found some really creative ways to use this top row and the availability of pins 1, 2, 3, and 6. Um, and yeah, they're just more creative than we are in some of the applications that you can use these for. So just because I look at this and say pins 1, 2, 3, and then 6 are available and we use it for data doesn't mean that's the only technology or the only application that you can layer on top of pins 1, 2, 3, and 6. Now, for the most part, that is what we're expecting to see, though, is that people are going to use data and you're going to use your meal ordering system or your checkout system or your patient engagement system and layer that on top of the the existing television content. The other option, if you do not want to allocate 24 switch ports to your television system, is to use the latest technology that we have, which actually embeds a layer 2 switch via this port into the ZHC. Now, we've made some modifications to this since we released it, and now it is a one-to-one relationship per front panel bank. So if you have a 24 port unit like you see here in this screenshot, you would actually have 3 input RJ45s on the back, and we would physically take this RJ45, it goes to that bank of 8, this RJ45 goes to the middle bank of 8, and this RJ45 would go to the far bank of 8. And the reason that we did that is this rear panel port is a 1 gig connection. And each of the front panel ports, as we covered on the previous slide, only have pins 1, 2, 3, and 6 available. Since they only have 1, 2, 3, and 6 available, the max speed that the front panel ports can sustain is 100 base T. So we have a gig port here on the rear panel, and then 8 100 base T ports connected to that gig port on the front panel. So we can share this gig speed across 8 ports, and that gives us over 100 base T available at each front panel port for our clients. When we had this system set up so that it was 1 gig port and then we had daisy chained these front panels internally, the issue that we ran into is that we were sharing this 1 gig of data capacity across potentially as many as 24 outbound ports, and it just wasn't efficient. We weren't getting the performance that we wanted out of the switches. So we changed the infrastructure a little bit in order to make this a higher performing device for ourselves and for our clients. The one thing that I do want to note here while we're talking about it is you will notice if you've got a network background, we are being a little bit unusual in that this is no longer a one-to-one relationship, right? I'm going to come out of the client switching infrastructure into this port, and then this port is now connected to 8 devices. Well, like the default security setting in a Cisco environment, let's say, is that you're only supposed to see one machine address, one MAC address per switch port. So you do have to make a couple of adjustments to your network infrastructure settings to make sure that you can support multiple MAC addresses off of that switch port. It's not that unusual, right? If you're connecting a wireless access point to your switches or anything else like that, you already kind of have to handle this and have to be able to set it up. But it is worth noting that we have occasionally had to have clients adjust some network settings to support this configuration where we're going from 1 port to 8 front panel ports and thus out to 8 client devices. So I want to just take a second and kind of compare and contrast the two there and give some positives and negatives of both. Um, Really, the biggest difference is that the pass-through option that we covered 2 slides ago is going to require a one-to-one relationship between the number of switch ports and the number of edge devices or the number of client devices. So if I have 225 TVs that need data connectivity, I have to allocate 225 switch ports within my system for data services running through the Z-Band platform. If I'm using this internal switch option, Over here, that relationship becomes now I only need one port for every 8 edge devices. So if I've got 225 televisions in a hospital that want to see IP content through the Z-band platform, I can divide that by 8. That's going to be what, under 30 switch ports that are going to be required, assuming that they're evenly spread across the hospital. And that's going to make life a lot easier on your network team in terms of cost of infrastructure, right? Because we've gone now from needing 225 data ports to support whatever data we're putting on the television system to needing, let's call it 30. It's actually 28 point something, but let's call it 30 data ports from the client in order to support those same 225 PVs. That's a tremendous cost savings. You just cut 190 switch ports out of your build as you go to this internal switch. So we do see a lot of clients head that direction, not necessarily because it's making the Z-band system cheaper, but because it is making the overall design and the overall architecture cheaper as they are able to eliminate some of the switch capacity. So they are being able to more, cheaper is probably the bad word, cost effective. You are building a more cost effective system when you go this route. However, we have seen, and it's this bullet down here, we have seen some hesitancy from IT directors to put these unmanaged ports on their network. And I completely understand that, right? Like, this is not meant as a criticism. This is meant informationally. This is what we've seen as Z-band when we talk to certain clients. And some clients are hesitant to put these unmanaged switches on their platform because they're used to seeing, okay, the TV in room 715 is down. I can go into the switch. I can look at that specific port and I can see that there's data passing through that port. So it's not a network issue. There's something wrong with the television and we actually have a problem out at the edge. You do lose a little bit of that granularity when you take a single switch port from the client and use it to feed 8 devices, because if one of those 8 devices is down, the client has no access to see what's going on in the Z-band switch or the Z-band infrastructure as to why that particular port may be down. So we are fixing that. The next iteration of the system that Z-band puts out will have some management capability or a management UI within that switch as well, so that that issue can be addressed. But when we see clients who want to go this direction, where we want to go with the pass through, that visibility is important to them, and that visibility is important to them on a scale that makes it worth spending the additional money in switching infrastructure to be able to support that. The other reason that we see this pass-through requirement or the request for pass-through is we just have so many existing clients who that is how their system is set up and that is how their system is run. I mean, I don't, not to put like too fine of a point on it, but the company was started in 1999. We started selling top row, bottom row equipment in 2005. And then from 2005 to 2019, every device that went out the door was a top row, bottom row device. So there's just a massive market out there for these Gen 3 and Gen 4 customers who want to continue utilizing the system in the way that they have always been utilizing the system. And we do see a lot of the top row, bottom row comes from that as our clients. The nice part about it for both of them is because of the new design for the internal switching system, you have full 100 base T speed available at every data port that we're sending out as Z-band. That's going to be more than sufficient for anything you're doing from a video on demand standpoint. It's going to be more than sufficient for anything that you're doing in like a Netflix or streaming standpoint. 100 base T doesn't sound like it in the era where we have 40 gig backbones and 100 gig backbones and everything else that we have in the enterprise environment. But 100 base T out to the edge, when the edge is most of the time a television, is plenty of speed for a lot of the applications and a lot of the technologies that you guys are going to be using. And what that actually looks like when you're out in the client at the edge is the Balun receives the category cable coming in, and then it's going to split pins 7 and 8 RF out to the TV as coax. Pins 1, 2, 3, and 6, 10, 100. In this one, we have this drawn to, let's call it a smart TV or healthcare grade TV as well. It could be a little set-top box or a PC, Intel NUC, whatever that sits back here. As long as that data is being connected to something behind the television, that's really the point of the architecture. So it's pretty straightforward. And from your standpoint as the client, it's all passive, right? There's nothing that you're doing here that's a configuration. You are just connecting this data cable to a device that wants to see an RJ45 connection, the same as you would if you were passing it through any other Ethernet switch that you happen to have in your environment. So this is not something where there's anything that's special or unique or different about what Z-band is expecting you to do here. We're just passing through data. And I'm going to make sure I say this out loud. I'm sure everyone on the call understands, but data by its own nature is bidirectional. So unlike earlier in the presentation where we have to have this dedicated reverse path infrastructure for RF coming back, you don't need to have this dedicated reverse path infrastructure when we're dealing with data. And again, I'm sure everybody knows that, and I'm sure everybody understands that. It is also worth pointing out, though, that this is basically it in terms of the specialized infrastructure that you need if you're pushing data through your Z-band system. It's just what you're doing at the Balun is the only thing that's really unique. Uh, so yeah, to summarize, we're 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 in a good spot right now. This is unusual for me to be saying because I'm kind of like more of a pessimist by nature. I'm not the world's most chipper, happy-go-lucky person who thinks that everything is always going to work out great. But we are in a good spot because we've learned our lessons from the last couple of years where we put out what we thought was a product that was on the edge and ready to kind of take our RF technology into the next generation. And it was to some extent, but it also had neglected a little bit some of the legacy customers and legacy clients that we had that had been doing things the way that they had been doing it for 5, 10, 15 years along with us. And then we released this new product and needed to catch back up with our legacy customers, which is kind of an odd way of looking at it, but that's exactly what needed to happen. And the great part about it is from a Z-band standpoint, it's now made us more flexible and more adaptable. So if we have to have RF reverse path communications, we have a solution for that. If we want IP communications in that traditional pass-through environment where we have a one-to-one relationship between switch ports and edge devices, we have a solution for that. If the client is willing to put an unmanaged layer 2 switch on their network and wants to reduce their port count and reduce the number of switches that they need to buy in order to be able to purchase or implement a Z-band system and a patient engagement system or a meal ordering system, whatever it is that they're using, we have a solution for that that allows them to reduce that network footprint as well and reduce the number of switches that they need to procure. So it has made us a lot more flexible in terms of the solutions that we can offer clients when they want to tack things that aren't Z-band things or necessarily directly Z-band things on top of a Z-band system. And to me, that's the part that's exciting about it. The more solutions that we can offer, the more flexible that we can be to you guys, to our clients, when we're doing things like this, the better off we are. And that's really what the purpose of this webinar is. That's how this ties into video on demand and patient engagement and all of those other kind of technologies that we talked about last month, is that what we've covered over the last half hour is why Z-band is more adaptable and more flexible when dealing with these technologies than what we were 2 or 3 years ago. And we're pretty excited about that. I'm excited about that. And I am almost a half an hour on the dot, which is what I normally aim for these things. So I will stop. There is a question bar, chat bar in the tools that we have available. So if you would like to chat in a question right now is the time to do that. I'm going to kill my laser pointer and stop talking for a bit. All right. I do not see anything in the chat or in the Q&A. I am going to wrap this one up, and I'm sure you'll get a follow-up from our marketing team. And if you want the copy of the presentation or anything, please just feel free to reach out and we'll make sure to get that to you. Thank you very much. Talk to everybody soon.